Okay, so here we have a semi-truck that is initially moving eastward at a rate of 18 meters per second, and then it says that the driver slams on the brakes, bringing the truck to a complete stop. And then it says if the semi-truck decelerates uniformly at a rate of 4 meters per second square, and wants us to find A, B, C, D, E, and F. So if you need to, pause, read, keep up. All right, so for this particular problem, I'd like to point out a few things. The detail stuff is going to dictate, your outcome here. So as you read these acceleration problem, it's important to identify whether, quantities of vectors versus scalar, and then make sure your signs are right. Okay. All right, so I'm going to highlight a couple things here. Here it says the semi-truck is moving eastward, so to the right, at a rate of 18 meters per second. So right away, I know that my initial velocity is positive because it says eastward. Okay. The other word that's important here is just decelerate. Well, decelerate in physics just means that you're slowing down. Decelerate does not mean negative acceleration. It doesn't mean positive. It can actually be either one. Okay. So a common misconception is folks might read the word decelerate and think it's negative, or they might read the word decelerate here in this problem and just see that this is 4 meters per second squared and keep this quantity as positive. So as you practice, you need to establish the direction for your velocity and then the direction for your acceleration before you crank out any sort of calculations. Otherwise, you'll goof on the outcome. Okay. Now, in case you go, well, how do I know if it's positive or negative? I think this particular diagram really helps folks who are newer. Okay. There are 4 possible scenarios here. There's A, B, C, and D. For the problem that's presented in this particular video, it matches with B because it states that the car, or in this case the truck, is moving eastward to start with. So I'm going to pick this diagram because the velocity vector is pointing right. And the word decelerate here suggests that the vector for acceleration is going to point leftward. So the motion is being slowed down. Okay. So it needs to match one of these. So before you do any calculations, make sure you have to pick which is the scenario, because they'll tell you whether V is positive. So in this case, I know my V is positive and my A needs to be negative. All right, so let's do it. Now, here's the truck. Okay, here's the diagram. Here's my velocity vector. That's positive 18 meters per second. Once again, I know the problem just gives you the number 18 meters per second, but I'm just gonna go ahead and put a positive sign, or just draw an arrow to the right, and hopefully that helps you keep up with the vector stuff. All right. And here's my acceleration. My acceleration for this one is actually going to point leftward because in order to bring a car that's moving eastward to a stop or slowing it down, your acceleration vector must be opposing it. Opposing it would be leftward in this case. So while the problem states that it's 4 meters per second square, I know that my acceleration must be negative for this particular problem. So I highlight the negative sign there for you. And this is what I'm talking about. If you don't recognize that acceleration is negative here, you end up plug in positive A for your calculations, and it's gonna cause all your answers to be jacked up. Okay, so establish your signs first, hopefully correctly, before you do any calculations. All right, so let's go ahead and crack out part A. Part A wants us to find the time that it takes for it to stop, suggesting that our final velocity is 0, and then we also know the initial velocity here, which is 18 meters per second. So to find time, A is equal to delta V over delta T. I'm just gonna move delta T up to the top left, at the same time move A to the bottom right, or you can cross multiply, whatever you want to do. So here, I'm just going to go ahead and say that time is equal to the change in velocity over the acceleration quantity. I'm just going to break up delta V, just for the sake of helping you out here. Delta V is VF minus VI over acceleration. Well, what's my VF? It came to a stop, so my VF is 0. What's my initial velocity? It's a positive 18 because it's moving eastward to begin with. Well, what's my acceleration? It's negative 4 meters per second square. So I'm just going to plug those values in. Okay, so once again, I emphasize signs here, directions. Otherwise, you're going to get a quantity that might not make sense. Here, the negative signs will cancel out. There's a negative sign on top, and there's a negative sign on the bottom, because 0 minus a positive quantity is a negative number. And then if you just do 18 over 4, you'll get 4.5 seconds. All right, so that is the answer to part A. All right, now part B wants us to find the truck's instantaneous velocity after 1 second. So if you haven't watched acceleration video 1, please go back to it. I'm just going to go ahead and use this function, which is really derived from here, okay, or from here, whichever. But if you kept up with the first video, you know where this function comes from. It's just icing for VF using the average acceleration equation. So VF, or V instantaneous here, is just the acceleration quantity times the time interval plus the initial. So here it says after 1 second. So I'm going to start at 0 second and just go to 1 second. which is a difference of 1 second. So my acceleration is a negative 4 meters per second square. My change in time for part B here is just 1 second. Well, what's my initial velocity for this particular problem? It's initially moving eastward, so my initial velocity is a positive quantity. All right, so therefore negative 4 plus 18, well, negative 4 times 1 is just negative 4, and negative 4 plus 18, right, will just give you, positive 14 here. So here in my answer, I highlighted the positive sign because they did ask for velocity, which is a vector quantity. So I do need to give a direction. So, or you can say 14 meters per second eastward. I'll just put the plus sign here because the plus sign is implied eastward in this particular problem. All right. What I meant earlier was, you see the second step here, right? I know the problem states that it decelerates uniformly at 4 meters per second square. This is kind of a trap layout for, new folks. Some folks might just think this is positive, and then they'll put in a positive 4 in the second step here. Well, if you put in a positive 4, 4 times 1 is 4, and then 4 plus 18, is 22, which contradicts the scenario, right? The truck is supposed to be slowing down, so the velocity should be decreasing, not increasing. And so pay attention to your signs, okay? All right, so that is the answer for part B. All right, now let's go ahead and crack out part C, D, okay, E, and F. All right, so here's the next truck, or here's the next second over. Here's the truck, and here I drew the velocity vector just a little smaller. So now this is plus 14 meters per second. So for every second, the magnitude of the velocity here decreases by 4. So it went from 18 to 14. Once again, these problems are assuming acceleration stays constant. So therefore, here's acceleration, which is still negative 4 meters per second square. And if you're keeping up now, the next second over is pretty light work, right? So it's going to go from 14 to 10. So the velocity vector is going to get a little shorter. And then from 10 now down to 6, because every second, you would just subtract 4, 4, 4. Okay, eventually to whenever it stops. All right. So hopefully these values are pretty quick for you to arrive at by understanding what acceleration really represents. All right. So here's C. C asks you to find the truck's instantaneous velocity after 3 seconds. So C is really B, except with a different time interval. So I'm just going to go ahead and do it just for the sake of, helping you out here. F is equal to A, change in time, plus VI. A, once again, is negative 4 meters per second squared. Change in time for part C here is 3 seconds because it says after 3 seconds. So I'll go back to 0 second, go all the way to 3 seconds, which is a change of 3 seconds. And then VI is 18 because I'm starting at 0 second, right? So at 0 second, the car was already moving, so my initial velocity at times equal to 0 is 18. So make sure you plug in values that are consistent with the bounds that you set up. All right. Once you do that, negative 4 times 3 is negative 12, and then negative 12 plus positive 18 is 6. Okay, and the plus sign there, the plus sign there is just for the direction because it asks for velocity. All right, so that's the answer for part C. So you would say that at 3 seconds, it's moving to the right at a rate of 6 meters per second, or 6 meters per second east or eastward, whatever. All right, let's do part D. Part D asks us to calculate the change in velocity during the 3rd second. So the wording here in part D is a little tricky. If you don't read it carefully, you'll goof. So if you're listening now, maybe really hone in on the wording. So it asks for change in velocity, the function to find change in velocity. Again, just manipulating the average acceleration equation. So we can say the change in velocity is just acceleration times change in time. Well, what is your change in time? And that's where the wording here is going to be a little tricky. So listen and watch. Okay, it says the 3rd second. The 3rd second is not 3 seconds, right? So part C and D sounds similar, but they're totally different. The 3rd second suggests that it actually starts at 2 seconds and go to 3 seconds. Okay, so the 3rd second implies just a 1 second interval, because 3 minus 2 is 1 second. But the 3rd second starts at 2 and it ends at 3. So watch my cursor. Okay, this is times equal to 0. To go to 1 second, that's called the 1st second. And once you get to 1 second, to go to 2 seconds, that's called the 2nd second. And then once you end up here to go to the next one, that's called the 3rd second. So you notice here the 3rd second starts at 2 and it ends at 3. Okay, because if you plug in 3 seconds, you're gonna goof. So change in velocity is equal to a times change in time. Acceleration, once again, is given in the problem as -4 meters per second square. The change in time here is just 1 second. Do not plug in 3, okay? And that comes from just wording. The third second is just a difference of 1 second because it starts at 2 and ends at 3. Once you do that, I mean, it's pretty easy, right? -4 times 1 is just -4. So because I asked for the change in velocity, I'm just going to give you a negative sign here. So in this case, we just say really the change is -4 because the acceleration itself is -4 meters per second square. All right. So change in velocity here is -4 meters per second. Now, if you wanted to, you can totally find change in velocity by doing this. Well, on a physics function note, delta v or delta anything is that variable in the final frame minus the initial frame. So delta v can be broken up into vf minus vi. Well, to do this approach, you need two quantities. What is the final velocity and what is the initial velocity, right? Well, this is pretty easy to do. Well, what is your final velocity? 6. Well, how do I know that? Once again, watch my cursor. From 0 to 1 second, that's called the first second. From 1 to 2 second, that's called the second second. From 2 to 3 second, that's called the third second. Well, we ended here, so our final velocity here is 6. Our initial is 10, hence VF is 6 minus VI, being positive here, so minus 10. So 6 minus 10 is -4. So you see, it all depends on your decision in terms of which approach you do, but the answer must be consistent, okay? All right, so as you can see, it doesn't really matter which approach you take. You get -4 meters per second for the change during the third second. E wants to find the ratio. If you've seen the first video, this is kind of a repeat on that particular skill. I think it's important to just kind of practice ratio stuff. All right. So here's the general statement in part E. It wants us to find the ratio between the change in velocity for the first second, and then compare that to the change in velocity between 1.2 to 2.9 seconds. So to do this, I'm just going to find delta V twice based on the time interval given. So the first one I want to do is this one from 0 to 1. Well, delta V is just acceleration times time. So back to this statement in the middle here in green, change in velocity is simply a times delta t, right? It's just one function, but that's being used multiple times here. Well, a is -4. Time here is just 1 second because from 0 to 1 is just 1 second. -4 times 1 is -4. And then I want to do it again for the second statement on the right. The second statement on the right wants us to find the change in velocity from 1.2 to 2.9. So 2.9 minus 1.2 is a difference of 1.7. So once again, A is stay the same, and then change in time here is 1.7 seconds. And if you multiply on your calculator, you get -6.8. So I'm just going to substitute these values in. On the left side in orange here, instead of writing all this sexy stuff, I'm just going to put -4. And then on the right, I carry the blank down, or the coefficient down here. And then the value for 1.2 to 2.9 we just calculated, which is -6.8. And then I'm just going to put a little star, put a little X, put a little heart, whatever it is you want to do. It really is your unknown, right? The blank represents your unknown. What coefficient do you have to multiply by to make it a true statement? Well, to find star, you need to divide both sides by -6.8. And this is in parentheses, so don't add. Anytime things are in parentheses, it's the operation is to multiply. So to get rid of -6.8, you do the opposite operation, which is to divide. Okay, divide both sides by -6.8. 4 divided by 6.8, and that'll give you a value of about 0.588, and that's it. So the coefficient that would make this statement true is 0.588. Okay. Now, if your big brain is up and running, anytime I ask you to find the change in velocity, really, you're just finding the coefficient or the ratio between the time interval. So from 0 to 1 is just 1. From 1.2 to 2.7 is 1.7. So if you want to pick up your calculator, to solve for this blank, you would just take 1 divided by 1.7, which will give you the same coefficient because A is a constant. Okay. So you can apply that for this particular problem because A is a constant, so it'll cancel out. So really, you're just looking at the change in time. Okay. All right. Try it out. So if you plug in 1 divided by 1.7, you'll get the same answer. All right. Let's do part F. Part F asks us if the initial speed is double, right? So instead of 18 here, it'll double to 36. So how would that affect the braking time? Well, using common sense, we know that if the initial speed is faster, under the same acceleration, it would take more time to stop, right? So it's like on a highway, if you're moving at 40 miles per hour, you would require a certain time to stop. Now, if you double it to 80 miles an hour, I think intuitively you would say, well, it would take me more time to stop. Now, so here's your average acceleration equation, a being constant. So the problem here states, what if the initial speed is double? So I just drew an arrow for you here. So if delta v here goes up by 2, right? Well, because a is a constant, t has to change too. But how does t change in order to keep a the same? Well, I would say it has to double, because 2 divided by 2 is 1, which makes it the same quantity. So for that reason, if the initial speed is double, the braking time also needs to double. Why? Because a must remain constant. So if the numerator is multiplied by 2, the denominator also has to multiply by 2 for that statement to be true. Okay? All right, I hope that helps. Stay nerdy, don't be whack.